learners, today we are going to study self-service model in operation research for second MSc mathematics students. This presentation will provide an overview of the self-service model, a fundamental concept in queuing theory and operation research. We will explore the key components, assumptions and applications of this important model. Assumptions and characteristics of the self-service model. In this model assumes that customers arrive at the self-service facility following a Poisson process with a constant arrival rate. The second one, the service time for each customer is exponentially distributed with a constant service rate. The third one, the service facility has an infinite number of servers, so there is no waiting queue and all customers are served immediately upon arrival. The fourth point, the service discipline is first come, first served, that is FCFS, and customers are served in the order they arrive. The fifth point, the model has an unlimited waiting space, meaning there is no limit to the number of customers that can be in the system at any given time. Arrival and service process in the self-service model. Arrival process is Poisson arrival process. The Poisson arrival process is customers arrived at the service facility according to a Poisson process with a constant average arrival rate lambda. The second one, exponential service times. The exponential service times of customers follow an exponential distribution with a constant average service rate mu. The third one, infinite server assumption. The service facility has an infinite number of servers, so there is no limit to the number of customers that can be served simultaneously. Next one, steady state probabilities and performance measures. In this self-service model allows us to analyze the steady state probabilities of the system. This includes the probability of having n customers in the system and the long-term average number of customers. Key performance measures such as the average waiting time, average queue length and system utilization can be derived from the steady state probabilities. These metrics provide insights into the efficiency and throughput to the self-service model. Relationship between arrival and service rates. Arrival rate and service rate. The self-service model assumes that the arrival rate of customers and the service rate at each server are independent Poisson process. Relationship dynamics. The performance of self-service model is highly dependent on the relationship between the arrival rate and the service rate. This relationship determines the level of congestion and the wait time experienced by customers. Utilization factor. The utilization factor, defined as the ratio of the arrival rate to the service rate, is a key metric that captures the balance between the two rates. It is crucial for analyzing the system's efficiency and identifying optimal operating conditions. Optimization potential. By understanding the relationship between arrival and service rates, system designers can optimize the self-service model to achieve a desired performance targets such as minimizing waiting times or maximizing throughput. Optimization of the self-service model. Optimization of the self-service model contains optimize service capacity, manage arrival rate, improve service efficiency. Optimize the self-service model involves carefully balancing the trade-offs between service capacity, arrival rate, and service efficiency. By adjusting these key parameters, organizations can minimize wait times, reduce operational costs, and enhance the overall customer experience. Applications and uses cases of the self-service model. The applications of the self-service models are retail and customer service, IT support and service desk, banking and financial services, hospitality and travel. In retail and customer service, the self-service model is widely used in retail and customer service settings to optimize self-service and improve customer. IT support and service desk. This model helps IT support teams manage the influx of service requests and optimize resource allocation for efficient problem resolution. Banking and financial service. Banks and financial institutions leverage this model to design and operate their self-service ATMs and online banking platforms. Hospitality and travel. The self-service model is used in hotels, airports, and other travel-related services to optimize self-check-in and self-service kiosks. Limitation and consideration of the self-service model. Oversimplified assumption. The model assumes infinite servers and exponential service times, which may not allow reflect real-world scenarios accurately. Second one, lack of customer prioritization. The model does not consider priority-based service or queue disciplines, which can be important in certain applications. The third one ignores spatial constraints. The model does not account for physical space limitation or layout consideration that can impact service operations. Conclusion. Limitation and consideration. Versatility of self-service model, importance of balancing arrival and service rate, key takeaways for MSc students. The importance of balancing arrival and service rate. Maintaining the right balance between customer arrival and service rate is crucial for ensuring efficient and satisfactory operations as explored in the model. Limitation and consideration. While powerful, the model has limitations such as the assumptions of Poisson arrivals and exponential service times, which may not always reflect real world scenarios. Thank you.